We've seen thus far that feed-forward neural networks are not very good at doing image classification. What we want instead is something that is more similar to human intuition, where we have low-level patterns that are picked up, then mid-level patterns, high-level patterns, and then a final detection. And this is where convolutional neural networks come in. Convolutional neural networks, or CNNs, use convolution filters to automatically learn spatial patterns in data. A convolutional filter here is the same as a kernel, and it is just a small matrix of learnable weights that slide across an image performing dot products. Each operation produces a feature map that highlights learned patterns such as edges, textures, etc. We can look at an example here where we have the input image of a dog sitting in grass, and we have different kernels, so different matrices that we slide over this input image. So in this first case, this red case, we have an edge detector, in the green case we have a texture detector, and in the third case we have a color detector. For instance, this first one here, as we slide this matrix over this image, this gives us this output feature map, which gives us all of the edges that it detects. The second case, this is for texture, so as we slide this matrix over this image, we get all of the fur that it detects. And the third case, this detects the color, so it detects all of the brown, for example. So as we slide it over this image again, we get all of this out here. So you can think of this in an example that we had with a picture of a dog, as in, for example, this kernel gets all of the ears, so this highlights the ears in the picture, this one highlights the eyes, and this one highlights the nose. Each kernel here captures certain visual patterns. However, in reality, CNNs don't have distinct filters that isolate semantic parts such as eyes and ears. Rather, the kernels work together to represent low, mid, and high-level features that collectively capture what it means to make an image, in this instance, dog-like. So for instance, early filters will highlight edges and gradients, middle filters will respond to textures and shapes, and then late filters will capture abstract configurations relating to the object identity. Please check out the full video on YouTube for more.